right, everybody. This next workshop is brought to you by Blues Wireless, a connectivity company that enables you to write code once and deploy it across Cat1, LTE-M, NB-IoT, or 2G Cellular, plus Wi-Fi and LoRaWAN. Rob Lauer and TJ VanToll will be showing us how to connect and scale a network of distributed smart city devices to the cloud across swappable protocols using a single code base. Welcome.
Thank you very much, Alex. Start sharing my screen right away.
Looks great.
Good. So welcome, everybody. I'm going to advance my slides here. So thanks everyone for joining us here at Hackster Impact Summit. I'm not going to lie to you. TJ and I are here to spice it up a bit. This kind of feels like that session right after lunch. You know, everyone's all tired. So we're totally going to re-energize you all by talking about wireless connectivity and sustainable cities. I mean, that's really all I need to say, right? Well, maybe not, but I do want to start with some really quick intros. My name is Rob Lauer. I'm Director of Developer Relations here at Blues. Alongside me today is TJ VanToll, who is our Principal Developer Advocate. And we'd both like to thank Hackster, of course, again, for inviting us to present at this event. So who is Blues? What is this Blues thing? Well, if I can oversimplify what we are about, we provide hardware and services that back up this message of making wireless connectivity easier for developers and more affordable for all. Which, yeah, it's a little bit of a marketing line, but I think it is true. And a big part of what we are about is revealed through this phrase of wireless harmonization. Now, this is the idea that product builders, so you and I, should be able to build really future-proofed IoT solutions choosing the radio access technology almost as an afterthought, allowing us to change deployment regions, deployment types, cellular, Wi-Fi, LoRa, whatever it may be, almost at the last second. So why is this important? Well, for most modern IoT apps, choosing between cellular, Wi-Fi, and LoRa is a decision you're forced to make upfront before even starting development, right? Partly because of incompatibilities between radios, maybe provisioning issues, maybe deployment models. So you effectively need to program specific to those technologies. And at the end of the day, do we really care that much if we're using LoRaWAN or cellular or Wi-Fi or even satellite? Or do we just want to get the dang thing connected? And of course, have it be reliable and effectively future-proofed. So this is where the idea of wireless harmonization comes into play. Because in this magical harmonized world, choosing a radio access technology or a RAT can be a deployment time decision instead of a development one. So you can effectively develop a solution, and when it comes time to deploy, then you make the choice of cellular or Wi-Fi or LoRa based on the specific needs of the actual destination you are deploying to. Now, this idea of wireless harmonization, it goes just beyond, harmonization of RAT or radio access technology. It also includes harmonization of location gathering technologies and the harmonization of data flow that you'll see we get from the Blues Cloud Service and Node Hub. And we're going to touch on all these briefly today. So what does Blues really have to do with sustainable cities? Admittedly, Blues is a horizontal solution. We have customers in every industry out there, not just cities, not just municipalities. But what is important for local and regional governments especially is everything that falls under that sustainability umbrella. And to me, that starts with future-proofing and long-term cost savings. For example, if you're deploying a solution in one part of a city that has reliable cellular, but in another that only has access to Wi-Fi, you don't want to program that device differently, which is why Blues connectivity options share not only the same physical connector, physical footprint, but also the same developer API. Also, when looking forward at the inevitable 4G LTE sunset, you don't want to be caught in that, right? You want to have a path forward. And Blues is thinking along those same lines in terms of future-proofing our future solutions, if you will, with the same physical footprint and the same API. And when it comes to like literal sustainability, Blues is really attractive as everything that we provide product-wise is low power by design. For example, our cellular product only consumes 8 microamps when idle. So it's even less than the drain of a LiPo battery. Finally, when looking to the future, again, even if Blues were to go out of business, you're not stuck. As I'll get to in a second, our cellular products include 10 years of prepaid global service, that never goes away. Your device will still function without Blues. So what do we actually provide? Well, this is one of our note cards. This one in particular is a dual cellular and Wi-Fi IoT device. It comes prepaid with 500 megs of data, 10 years of global service. That's all baked into the cost of the device. There's no subscription fees. There's no monthly SIM fees, no monthly data fees. But the note card, the hardware is only half of the story. The other half is our cloud service that we call NoteHub. And the two work together to form what we call a device to cloud data pump. In practice, what this means is developers are going to buy like a starter kit from us, hook up a sensor to it, and start reading data with that host microcontroller, and then deliver that data securely over cellular or Wi-Fi or LoRa to NoteHub. NoteHub, and most importantly, will then route that data to their cloud. So to be super clear, NoteHub, it's a cloud service, but we're not trying to create a platform that locks you in. We exist to help you connect it to your platform. Maybe that's AWS, maybe it's Azure, maybe it's Google Cloud Platform or DataCake, something like that. So we're really trying to help solve the messy, complicated middle piece of connectivity so that y'all can easily and securely connect your devices to your cloud applications. But there are a lot of note card options on the hardware side, again, depending on the RAT you want to leverage. But the good news is that they are all swappable again. So we start with the existing, we have this line of cellular only note cards. It's a great option if you only need Cat 1, LTE-M, or NB-IoT based cellular. There's also a Wi-Fi only note card based on the ESP32S3 chipset. There's also a brand new LoRa only note card, the note card LoRa. And a new set of developer of dual cellular and Wi-Fi note cards that allow for using either cell or Wi-Fi, or even a Wi-Fi to cellular fallback feature. Again, note that all of these use the exact same physical M.2 connector on the bottom. Now, zooming in on the note card just a little bit more, the note card is, of course, the core hardware that we provide. It is a low power system on module, I already mentioned, measures 30 by 35 millimeters, up to 30 by 42, I believe, for the new dual cell and Wi-Fi note card. Again, has that M.2 edge connector at the bottom for embedding in your project. Again, there are cellular, Wi-Fi, and LoRa variants. The cellular one includes GPS connectivity, GPS module as well. And as mentioned, I think it's the third time I'm saying this, prepaid 500 megs of cell data, 10 years of service. You can top them up with more data as needed. Importantly, the note card includes an embedded SIM, an onboard embedded SIM, but also provides support for dual SIMs. So if by any chance you're in a country that we don't support out of the box, you can add a secondary SIM and use that. One thing that's really unique about Blues is our APIs. The way you interact with a note card is all JSON based. So you're not issuing manual AT commands, if you've ever done that before, to manage your cellular radio. We provide a very friendly, very easy to use JSON based API. And along with that JSON based API, we have well supported SDKs for Python, Go, Arduino, C, and Zephyr as well. And there's also note card cellular varieties that work globally, again, using those popular cellular standards. So again, everything is JSON in and JSON out with the note card API. And as an example, if you wanted to get your note card's GPS location, this is the request you would issue. Very straightforward, card.location. And it's going to return the requested location in the JSON formatted response. The rest of the API is set up very similar to this. But if you're asking yourself, like, JSON and C, isn't that kind of weird? Yeah, our libraries extract that complexity out. So you're still making JSON requests and parsing JSON responses from the note card, but all in C. It's quite friendly. So that's what the note card really brings to the table. But just as importantly, it's super important to know what you don't need when you're choosing the note card. You don't need your own SIM or mobile plan. As mentioned, the note card comes with an embedded SIM with global support. You're not issuing those AT commands, or you're not managing cellular connections manually. It's a huge pain, trust me. You're not rolling your own security. So the note card hardware itself includes the system on module, includes an integrated ST-safe secure element with hardware crypto. There's a random hardware random number generator rather, and a factory installed certificate that's provisioned at chip manufacturer. That's all on the board. For firmware updates, the note card and NoteHub together combine to provide incredibly easy ways to update both host firmware, so your host microcontroller, ESP32, STM32, or Nordic, or the note card firmware itself as we release new fixes and feature updates. And you know what, you're always doing some kind of power management with any given solution, especially if it's battery powered. But it's important to know all the components on the note card itself are low power by default, as are the default configurations in the note card's firmware. You can override them as you need. And as you'll see today, again, securely sending data to your cloud endpoint is baked in. It's quite simple. And on certification front, the note card is FCC and PTCRB end product certified. So in most cases, our customers find that they don't have to acquire separate certification when using the note card for connectivity. That was a lot. Now, to make it easier to use your note card when you're prototyping or even when you're ready to deploy, frankly, we provide carrier boards called note carriers. And these are development boards that allow you to snap in a note card and connect it to really any solution you can dream up. I'll just run through them super quickly here. The note carrier F, for instance, that TJ's holding up, includes a feather compatible socket. It's kind of a nice all-in-one board. The A model includes onboard antennas and header breakouts to let you hook it up to any host microcontroller you want, really. The B is a small form factor note carrier, barely larger than the footprint of the note card itself. The note carrier Pi is a Pi hat for connecting with any Raspberry Pi or Raspberry Pi Zero compatible single board computer. We actually have a new version of this that's just out. I haven't updated the pictures yet, though. Next from SparkFun actually is their MicroMod cellular function board. So this you can use a note card with this, and it fits in with their MicroMod ecosystem, which is awesome. Great prototyping platform. And finally, Rack Wireless just released Blues.1, which lets you use a note card in their WISP-Block ecosystem. So all great stuff there. So everything I kind of went through quickly is kind of what we mean by harmonization of radio access technology in terms of building these sustainable products. So you choose whatever interchangeable RAT you need with Blues, right? Swappable connectivity, using the same APIs and providing future-proof deployments. I want to next talk really briefly about location, because a lot of the IoT products that we are designing have some need for ascertaining the device's location. But all location-aware devices are certainly not created equal, right? If you're using GPS, for example, I'm going to gamble that you can pretty easily ascertain a location here, like in a parking lot, in open space, clear view of the sky. But what happens when your asset moves indoors? You're kind of limited by GPS, right? You don't have access to those satellites. So while GPS is fantastic and it's the most accurate of all location technologies, it does suffer from the fact that it's power hungry. It can take a long time to ascertain its location as well. It also doesn't work at all indoors, which is what I was just kind of getting at. So what can we do about this? Well, we don't really have time to dive into this much today. All of our note cards that include Wi-Fi, they also have access to this feature that we call Wi-Fi triangulation. This allows the note card to automatically use public Wi-Fi access point data to ascertain device location. And it is shockingly accurate, I'll be honest. It's also extremely power efficient, way, way, way more so than GPS, also way faster to ascertain your location. And lastly, before I hand it over to TJ, I did want to briefly touch on the last of our 3 harmonization topics, and that is harmonization of data flow. And that starts with our thin cloud service, NoteHub. So NoteHub is the Blues cloud service that receives data as a proxy from the note card and securely then routes it to your cloud application of choice. Also within NoteHub, you can manage fleets of devices. That's really important. You can update, I mentioned this earlier, update both host microcontroller and note card firmware over the air really quickly too. NoteHub is also all about security. So securely transmitting data both from the NoteHub and to your cloud. And what's really cool about this is, I mean secure as in data is transferred off the public internet via private VPN tunnels when you're using a cellular-based note card, can actually be encrypted as well. So there's no certificate management, no key rotation required. Cool thing is the note card knows exactly where to go as soon as you power it on. So to help visualize everything I've just thrown at you here over the last 10 minutes or so, let me walk you through this diagram. So with Blues, you're going to bring your microcontroller. We're not going to dictate what microcontroller you use or single board computer. You're going to use whatever sensors you want. You're going to use whatever programming language, whatever RTOS you want. We're not dictating any of this stuff. You're going to compose packets of JSON data that we call notes. They're just arbitrary JSON payloads, right? And these notes or these events are queued on the note card. They're saved on the note card. And then at a cadence you specify, whether it's immediate or every hour or every day, you can sync those with NodeHub. Now, again, we don't want your data to live on NodeHub. We want you to route that data out of NodeHub to your cloud application of choice. Now, you can optimize this payload. You can transform it on the fly if you want to, if you need to. But we really want that data to end up on your cloud app. Again, it could be a big cloud. It could be a UbiDots, Losant, DataCake, any IoT platform, and so on. But it's important to know that communication with the note card is bidirectional. So you can actually start on your cloud app. You can send a JSON-based request using the NoteHub API. NoteHub will then securely deliver that JSON payload to a note card or to a fleet of note cards. The note card will then deliver it back to the host. So this presents opportunities for like handling remote control scenarios or maybe updating, fleet variables all remotely, like a single device or an entire fleet of devices effectively. Now, before turning it over to TJ, I did want to mention in terms of Blues and our impact on sustainable or smart cities, are these Blues accelerators. So these are about 40 purpose-built IoT apps that show off how to use the note card in a variety of very practical solutions. All of these are free and completely open source. There's numerous smart city apps as well. You can find all these on our developer site at blues.dev/accelerators. And I think that's my last slide. Yeah, so let me turn the stage over to TJ for a demo, and I will stop sharing.
Yeah, so what I want to do is I want to take what Rob showed in the slides and kind of make it a little bit more real and show you some demos of what Blues actually looks like in action. And I'm going to show two different demos. For the first one, I'm just going to focus on the basics. So how do you actually use Blues? What does it look like? What is the experience like? And then I'm going to fast forward and show you more of a real world app, something that you can actually take, bring up one of the accelerators, show what that's looking like. So give you an idea of what something you could actually take and deploy and customize with Blues as well. So I'm going to start with the basics, just the absolute getting started with Blues sort of material. And for that, I'll start by showing the hardware. I held it up briefly, but I got my camera up here a little bit bigger. So what I have is the note card. So this is our system on module. This is a cell plus Wi-Fi note card. So this has both a cellular modem embedded within it, and it also has a Wi-Fi module as well. And you're going to see how those sort of interplay in this example I give. And then the rectangular board that is housing the note card is what we call our note carrier F. The F is for the Feather compatible headers. I'm going to be using a microcontroller alongside the note card for my second demo. But to start, we're just going to go note card and note carrier. Now to do that, I'm going to bring up my screen and bring up blues.dev, which is our sort of developer hub for all things development at Blues. And for this demo, all the hardware that I'm going to be using is going to be a part of our starter kits. So that includes a note card, a note carrier F, and a microcontroller that I'm going to be using for my second demo. So if you're curious, if you want to try any of this, the very prominent link on blues.dev is where you can pick that up and check it out. And once you have it, this big Get Started button is where to head next, because it takes you to our quick start tutorials, which is just our sort of curated way for getting familiar with how Blues works. And I'm going to give you like the whirlwind tour of this here today, to do the best we can in 30 minutes. And if you have any questions, I'd again encourage you to use like the chat and the Q&A. Rob won't be doing any talking for like the next 20 or 30 minutes. If you don't ask any questions at all, he's going to get very bored. So please ask any questions so we can help clarify some of this stuff. But all right, I'm going to head straight into the note card quick start. I'm going to immediately call your attention to the section you see on the right-hand side of the screen. It's something that we have at Blues that I think is pretty unique and pretty cool, where we actually allow you to connect to a note card through your web browser using a feature of Chromium-based browsers called the Web Serial API. So you might have noticed, and I'll hold it up just briefly, is that I have my note carrier connected through USB. And because of that, I can connect in my browser to the note card and form a connection And once I've done that, I can actually send serial commands to my note card directly within my web browser. And if I scroll down in this tutorial, you'll see that it's going to talk through how to connect up my hardware. And if I go down a little bit lower, I told you I was giving the whirlwind tour, you'll see the first example for you to run, which is going to be this card.version request. So I'm going to go ahead and hit try it and run it. And you'll see I get a response back from the note card. And I just want to pause for a second and point out a couple of quick things. So the first is that the note card's API is JSON based. So I'm sending JSON in as input, in this case, a request of card.version, and I'm getting JSON back as output, which is just going to give me some basic metadata about the note card, what type it is. It has Wi-Fi and cellular, it has GPS and things like the firmware version. So this is the absolute basics of communicating with the note card. I'm doing this communication through the web browser, but you can also send these commands through our firmware libraries. So if I go to our docs and open up our tools and SDK section, we have a section on the different firmware libraries that you can also use to communicate with the note card. So you see you can do it through Arduino, Python, Zephyr, C, Go, TinyGo. Just to say that all of these commands that I'm sending here in the browser, you can also probably in more of like a production scenario, send through our firmware libraries as well. And I'll be showing an example of actually the Zephyr and C one here in just a few minutes. But I want to show how to work with data with the note card, because this is just sort of just a basic to show you how the API works. And to work with data with the note card, you first need to set up NoteHub, so our secure cloud backend for working with the note card. And once you're in NoteHub, so it looks a little something like this, you can see different projects, which are just different ways of grouping your devices and the data that you use alongside the note card. I'm going to go ahead and create a new one for today. So we'll just call this Hackster and go ahead and create this. Again, a project is just a way of grouping your devices and your data in your settings for your account. And once I have this new project, the main thing I'm interested in is this identifier, which we call a product UID. And I'm going to copy it because I happen to know that the next step for setting up a note card is to run this hub.set request, which is just going to associate the physical note card that's sitting on my desk here with our NoteHub backend. So I'm going to paste that in and run it. And by making that change, I actually don't, if I go back to NoteHub, I don't see my device up here yet. It's because the note card is a low power friendly device by default, meaning any changes you make on the note card, at least by default, are queued on the note card. Using things like the cellular modem consume a decent amount of power. So we want to give you some configuration to basically tell us how often you should sync that data. So you can put the note card in what we call continuous mode. If you're going to be on mains power and you're not too worried about power and you just want to see things as fast as possible. Or you can also configure the note card in periodic mode and tell it to sync every hour, every 2 hours, every day, depending on the needs of what it is you're building. Or if you're running a demo or just testing things out, we also have a command called hub.sync, which will just take any data, any changes that have been configured on the note card and instantly basically push them up to the cloud. Now I did cheat a little bit and I ran one command on my note card before this session started, and that is a card.wifi command, which basically tells the note card if the note card has a Wi-Fi module, if it has Wi-Fi connectivity, basically just what network to use, just network name and password. And because I did that, this data was actually sent over Wi-Fi and is basically going to appear in my backend immediately because it is being sent over a Wi-Fi connection. And so I now see my data in the cloud up in NoteHub. I'm going to show how to work over cellular here in a second, but the Cell plus Wi-Fi note card, at least its default configuration, is to send data over Wi-Fi by default if a Wi-Fi network is provided, and then to automatically fall back to cellular if for whatever reason the Wi-Fi network is down or unavailable or not working for whatever reason. So I'll kill my Wi-Fi here in a second just to show you how that works. All right, so if I scroll down a little bit, once you've formed that connection, so I now have the physical device on my desk, I've now got the cloud backend set up. So at this point, I'm basically ready to start working with data. The easiest way to work with data with a note card is this note.add request, because you can just pass it a body of any sort of data that you're working with. So in this example, it's temperature and humidity, could maybe be location, some other different sensor, lots of other different things that you might want to push up to the cloud. For now, we're just going to take this hard-coded value and push it up. And once again, this value does not automatically sync because the note card is low power by default. So it's just going to queue it. So I'm going to run this sync. If you look up here, it's going to basically tell me when it's doing the sync, and it's going to say that it's doing it over Wi-Fi. So this data should appear up into the cloud pretty darn quickly, since it's doing it over a Wi-Fi connection. And I think it just went through. So if I go back to my NoteHub project and I go over to the events list, so events are what we call the notes that basically gets transferred over the network. I see that temperature and humidity that I just pushed across. So once again, this is being sent over Wi-Fi, and I had to configure the Wi-Fi network. But suppose Wi-Fi goes down for whatever reason. So you might have noted, if you were really quick, that the hotspot there, basically the network I'm using is my phone. And the reason I'm using my phone is because it gives me a hotspot that's very easy to kill. So I will kill the hotspot on my phone. So I now no longer have a network for the note card to use. And what I'm going to do is I'm going to push up the same note.add, and I'll just change something here so it's a little bit different, and push it up and then sync again. And I'll call your attention to these little status messages up here, because what the note card is going to do out of the box, just with its default configuration, is again try Wi-Fi, because this is a cell and Wi-Fi note card, and it's going to prefer Wi-Fi because Wi-Fi is usually faster. But it's going to say, I can't find the Wi-Fi. It's going to retry a few times before it gives up to see if it has a connection. And then it's going to automatically fail over to cellular. So in a second, you're going to see some status messages that it's going to be firing up the cellular modem on the note card and getting ready to send this data over cellular. Now, what's cool about this is that note that I didn't have to do anything special with the note card. Again, all I did with the note card before any of this demo whatsoever is that I set up that Wi-Fi access point. Otherwise, this is basically a factory reset note card. And what this gives you the power to do is basically deploy devices that can use Wi-Fi by default, but have a failover for when Wi-Fi is not available, which sometimes can be mission critical depending on the sort of thing you're building. Like if you're building smart city and you're building something for emergency response or something, some sort of system that is critical that data comes through at important moments. This is a great way to basically give you two different ways of sending and working with data. And it looks like that went through over cellular. So if I head back up here, you'll see there's my second one because I changed that temperature. And every time that the radio access technology or the way the data is sent across, you get one of these events that we call a session.qo, which is basically just some metadata about the note card. And if I go down in here, it'll show you the technology that was used to transfer this data. So in this case, it's LTE because I killed the Wi-Fi network. But again, the real power of the note card is that you just didn't have to care. You didn't care about whether this was sent over cellular and Wi-Fi. What you get is this really simple standalone module that you send commands and let the note card take care of the connectivity for you. Now, what this makes possible is really where the fun begins, because chances are you're not interested in this just because you want to send a very static list of temperature and humidity. You probably want to build something cool. Like when connectivity is easy, that sort of leaves you to worry about the fun things or the useful things or something that will actually improve whatever it is you're building. That's probably why you're here today. So what we did to kind of showcase what the note card could do is put together a series of what we call accelerators. And I think there was a link to this in the chat, or it's just blues.dev/accelerators if you want to check this out and multitask and sort of browse around. And what these are fully documented applications showing off how to use the note card and NoteHub to build some really awesome things. So Rob briefly showed this in his slides, but I'll just scroll through so you can get a sense of some of these different projects that are out there. These are built with different technologies. Some of them use Blue starter kits. Some of them use some different hardware. There's one or two that show off how to use Blues with a Raspberry Pi. There's lots of different things that you can do. The one that I'm going to be showing off today is one we call a heat index monitor. I like this one because it is based off of a real use case that from one of our customers and our users that was monitoring heat index across a series of schools. And if you look at this accelerator, you'll see we always list the hardware that you need. So in this case, this is kind of a standard Blues starter kit. So you have a no card, a no carrier F, and a SWAN. And really all you're connecting to this is a temperature and humidity sensor. So this is an Adafruit BME 280. This is a really, really standard just sensor for gathering temperature, humidity data, and can be used to derive heat index. A battery, a solar connector, and then also some housing. So if you are connecting temperature data and humidity data in an outdoor location, if you're doing it and you're really worried about accuracy, you do need something to shield that sensor. Otherwise, UV light's going to interfere with your readings. Now, I'm not going to go through in complete detail all of this project, other to show that all of this is sort of documented. This is sort of intended to be a completely documented project that's open source. The firmware is open source that you can take and either take verbatim. You could just take this project and just deploy it as your own, or you could take the firmware since it's open source and sort of tweak it to meet your needs. Now, what I'm going to do is just hook it up. So I am going to this is using the Blue Swan microcontroller that also comes in our starter kit. And the cool thing about our no carrier F is that it just slots right into it. And then I also, if I don't drop it, have the little BME 280 temperature and humidity sensor that just attaches through a quick connector. I kind of like this because this is all like Lego blocks, right? It's easy for someone that's horrible at soldering and putting things together, like me, to throw together. And I'm going to hook it up, and then I'm going to show you the firmware that is running on this. And Rob, while I'm bringing up Windows, is there any questions that came through? Did people listen to me, or anything I've missed as part of
Overall, we're all listening, totally engaged here. Now, a question we commonly get, I feel like we get this every time we do any sort of presentation, is a question about the country support for the cellular note cards. And that information is all in our data sheets in our doc site. So we do offer a variety of different cellular based note cards, again, depending on the country you need to support. There is I can't even go into them. There's so many different ones, but we do offer some global note cards that are supported in like 140 some odd countries as well. So that's probably your best bet. There are also North America and EMEA focused offerings as well.
Cool. All right, so I brought up the firmware, and just to show where this is in the docs, you see that there's a firmware section that walks you through the details of how to get this up and running, that you can go through if you're interested in this in detail later. What I want to do is just give you the high level overview of this. So this is, again, firmware that's completely open source and available on GitHub. And if you're not familiar with C, this might look very intimidating to you at first. But I'm going to try to convince you that it's actually not that bad and point out some things that are very familiar that you'll recognize right away. First of all, this project does require a product UID. You'll see this for any project you build on top of NoCard and Blues. So this is that exact same identifier that I used earlier when going through the quick start, except this time I created a separate project for this heat index one, just to have a different bucket, and I'll show some data from there in a minute. If I scroll down a little bit more, so there's some configuration here, and further down, there's this exact same request that you saw me run in the browser, this hub.set request, except this time I'm doing it as part of my firmware. So basically my Swan microcontroller is going to be talking to my NoCard and setting it up and telling it basically what sort of configuration I would like to use. So in this case, I have this in periodic mode. I'm using an outbound flag, which is basically telling the NoCard how often to sync data that you've accumulated up to the cloud. Now, how often you sync is probably going to depend on what sort of power, what your power situation is, what your battery is like, how good of solar charging you're getting, because this project is using a solar connector to recharge the battery. I have this set to like 1 minute because we're doing a demo, and I don't think we want to wait like 10 minutes at a time to see readings coming through. But this is, again, sort of the configuration you get with a NoCard to make these sort of things possible. Below that, there's some code to just set up the BME 280 sensor. And then in the code that handles the actual processing of the sensor values, you'll see this exact same note.add request that I ran through the browser. Again, though, using the firmware libraries to do this instead so that I can actually do this on the microcontroller and talk to the note card. So it's going to be getting data from the BME 280. It's going to be getting a temperature and a humidity and then calculating a heat index. And then here's that same note.add request, except this time this body, instead of hard coding some values, we're going to be building up dynamically. So we will add a temperature, we will add a humidity, and we will add a heat index. And over here, because once I hooked up my Swan, I already had this firmware pushed out to the Swan so that it was running and that we could gather some data. And you'll see it started up over here. It's got this hub.set request. It found the BME 280, and it's starting to just publish data. I think every minute it's publishing every minute. I think it's gathering data every minute as well, or it might be every 30 seconds. And you can see the conditions of my office. So it's apparently 72 degrees Fahrenheit with a decent amount of humidity in here. Now, on the cloud side of things, because I've set this to sync every minute, what I can do is I can head over to NoteHub, which I've got for here, and I just need to switch projects to go to my heat index monitor. And if I go to my events, you'll see the data coming through. It should be every minute or so, and it looks like it is. Yeah, I started it up like 3:20, so you see these starting to go through. I have this data.qo, and if I go to the body, I have the data showing up here. So this is a slightly more real-world example of what using the note card looks like. Instead of just configuring my note card in the browser, I have some firmware I wrote. So in this case, it's in C, it's running in the Zephyr RTOS, but this is something that you could also write in Python for a Raspberry Pi, something you could write in Go, you could write in whatever ecosystem and using whatever hardware it is that you are familiar with. You tell the note card how often to be communicating that data or syncing that data. So in my case, I set it to periodic mode with an outbound of every 1 minute. If I were actually putting this outside, I would probably set it to like every hour, because I think that's often enough to get a sense of what the heat index is like in a given area. And importantly, notice that I didn't have to do anything related to cellular or Wi-Fi or whatever. I could put a card.Wi-Fi request in my firmware, but really the power of Blues is that the connectivity part is not the part you have to worry about. You just worry about formatting up requests to the note card and then seeing your data heading through into NoteHub. Now, the final piece to the puzzle here, and this gets back, if you remember back to Rob's slides where he showed things moving from the microcontroller to the note card and then finally to sort of your cloud of choice, is what you actually do with this data. So I have my data coming through, it's showing up in this events list, but this is probably not the end state of my data. I'm not going to want to show my users this sort of raw table of information. So the last piece of the puzzle is what we call our routing system, and how you take your data and get it to the cloud, get it to your dashboard, get it to your database, wherever you want it to be. And we support routing for a number of different ecosystems. You can either send the data over just straight up HTTP or MQTT, or we have integrations for some of the bigger clouds, your AWSs, your Azures, your Google Clouds, as well as some other providers as well. You can also use the note card to do things like send alerts, like say your heat index monitor. You only cared if the heat index hit 100 degrees Fahrenheit and you wanted to send a text message. That's something you could totally do with a note card as well. Now, for my purposes, for a simple demo, I like using a dashboard provider called DataCake. DataCake is free to get started with, really easy to use, and powerful enough that you can build some really robust dashboards. And for DataCake, all I did, if you just go through their basic getting started experience, and you can do so if you go to our docs, and our search on our docs is really great. If you just search for DataCake, you can find a full tutorial for walking through how to set up routing to DataCake. You can also find tutorials for all of these other providers as well. So if you have one in mind, you're a big Snowflake fan, or whatever the case is, our docs can help walk you through the specifics. But in my case, DataCake I like because it gives you a simple URL. And because I have this route configured, you might have noticed that on the actual events I've been sending through, there's this little check mark. And this is just showing that the data routed through successfully. And if I go into the event, I can see that the data is flowing through to DataCake appropriately. So over in one of my other tabs, I think it's this one here, I built the world's simplest sort of DataCake dashboards for visualizing this data from the simple data flow that's coming through. So you can see the data cake, the humidity, or the data cake, the temperature, the humidity, the heat index, as well as some other metadata about the note card, the location. As Rob said, I could be getting the location over something like GPS or cellular, or even because I am using a Wi-Fi enabled note card through Wi-Fi triangulation as well, and build a really simple dashboard around this. Now, this is still sort of an oversimplified look at things, right? But you can envision the sort of thing that this makes possible. If you're routing your data out, you can either build your dashboard for devices, fleets of devices. You can kind of build whatever makes sense to you. To show an example that's actually live and that sort of plays into the smart city situation, we also make a product at Blues called AirNote, which is air quality monitors that is built on top of the note card. And there are dashboards here for end users to do things like configure the note card, because you can send data from the note to and from the note card. So you can push configuration settings down to the note card. And then by routing the data, you can also build more robust dashboards that look a little something like this. And apparently the air quality is remarkably good where I am right now, but also just different measurements, the location of where mine's at, build charts over time. But essentially, once you have this power where data is flowing through, you can do a lot when you don't have to worry about connectivity. And really, overall, and Rob, I think that's about all I wanted to show for this demo. I want to make sure we have some time for any questions that came through. But really, overall, I just wanted to encourage you, if you found any of this interesting, if you want to try it out for yourself, again, blues.dev is the place to go. The starter kit is the easiest way to get started with Blues. This gets started information. These tutorials are where you want to start. And then if you want to check out any of the more like fully featured examples of how to use Blues, these accelerators are where you can check out as well. And I think that's all I have. So I just want to check in and see what we missed.
No, that's great. Yeah, a couple of things. When we're presenting something like this, I know we're running up on time here. People like to know what other sorts of, like, what a real world product, like what are real customers building with the note card or building around the note card. And I think I mentioned at the beginning, but like what we are providing is very much a horizontal solution, right? It can be used anywhere, which is fun to say, but it's actually kind of difficult for us to market and promote it, right? Because it is useful in so many different applications. But we do have some of our biggest customers are in commercial refrigeration, for example. So putting the note card inside every single refrigeration device that they put out there to monitor things like temperature and humidity, and is a door being opened or is door left open, all these things you might want to monitor. But then all the way to like these wild ideas like using the note card as a one-time use and putting it into cement that's curing in a building, right? So they can measure from the inside the cure rate of cement, which is just like the ideas that people come up with are pretty amazing, and they're always really fun to see. Aside from that, another question that we always get is about, I know I said earlier, like you can use any microcontroller. Sometimes people are like, oh, there's too many options out there. Like, what should I use? And in that scenario, I still like to lead with the fact that you can really bring your own microcontroller. But we did, I guess it was probably about a year and a half ago, we released our own microcontroller. TJ was showing it earlier. It's called the Swan. It's an STM32 based microcontroller. It kind of threads the needle between being a power conscious module, but also pretty powerful. It's got a fair amount of flash on there and a quick connector for connecting peripherals. I like it. It's kind of our go-to for demos as well. So yeah, that's one good option. Otherwise, I think that's about all we had to show.